Welcome to the valve market forecast today, June 20th, and we are introducing a very new concept here, which is a whole sales marketing program around the unit forecasts rather than sales leads. So valve purchases in 2019 will be $64 billion. Replacement and repairs will exceed $50 billion. Purchases of valves by companies who are already purchasing valves will be 60 billion. In other words, most of the companies that are buying valves are the ones that'll buy that are repairing and replacing valves are the same ones that will buy the new ones. So this $60 billion market is predictable, and the unit forecasts for each purchaser are obtainable. Forecasts for each purchaser can cost effectively replace sales leads as the foundation of a market program. A change in marketing policies can be slowly implemented. A progressive program starts with the low-hanging fruit. For instance, our N028 Industrial Valves already has the corporate forecast for the top 200 purchasers that represent 30% of the entire market. Forecasts for each purchaser can be provided in an Excel format and can be uploaded into your CRM system. So how big a potential is a unit forecast that's takes only a portion of the market? Well, we can see this in, industry by industry over here, and that those units which can be easily identified will account for 56% of the valve purchases in 2019. A program which starts with these targets can then be expanded to forecast revenues for the smaller prospects, and then on to unique valve types. So you can get into line valves or valves of a certain size, shape, etc. Can be done as well. So the industry segmentation and opportunity on a unit basis is quite different from, for instance, the municipal wastewater portion of the market, where there are a relatively large number of smaller operators that don't dominate the market. And this is true in the water industry itself, other electronics. So the reaching the units of a certain size, you're only going to be penetrating about 20% of the market. In the water market, only about 30% by getting the by getting the larger units. And then this is quite different though in the power industry, where we can identify 80% of the units in a $7 billion market. So some of the smaller markets, the percentages are lower than 50%. But the bottom line is, with the easily identified units, you can identify a market of $36 billion a year, and it represents 56% of the total $64 billion market. So sales leads has been the typical way that inquiries are generated and the sales program is set up and supported by the reps and exhibitions and advertising. But since most valves are replacement, forecasts of purchases at each unit and plant are more useful than sales leads. Forecasts guide the representatives and make the whole program more cost effective than reliance on sales leads. So we're proposing a program where individual product forecasts for each unit and plant are the center of the program. And we can do that because, as you can see, we have a number of subsidiary services which provide the technical and market insights needed to make accurate forecasts of individual plant purchases. So we have the valve market report that already has the market size by industry, product, and country for actually 12 different valve types. We also do continuing very detailed market research on specific aspects of the market by type of materials, sizes, processes, etc. We also provide a number of plant databases on water, wastewater, refining, power, and other industries where we're actually tracking every plant. We have more of those plant databases for the US and Europe, except for refining and power, where they're pretty well balanced, and semiconductors, where they're pretty well balanced worldwide. We also track the major projects worldwide in a number of different services, everything from our clean room projects to the utility tracking system with weekly utility e-alerts. And then in terms of determining the actual cost per valve and how many valves will be used, of what type, we do have a number of decision systems on, again, coal-fired power, gas turbines, wastewater, refining, and other areas. The progressive program can start with the largest prospects, where for the very small investment, you're going to have a very large return as high as 20,000 to 1. For the medium prospects, size prospects, you can expect a return on your investment of 200 to 1. But even for the smaller projects that would make up the rest of that 90% of the market that we can identify with the units there, you're talking an ROI of 5 to 1 in the first year, but then the cost goes way down, and therefore in future years the ROI skyrockets. So in truth, you're averaging 25 or 30 to 1 or greater on the ROI over a period of years. So the progressive program starts with forecasts for large power, refining, pulp, mining, semiconductor, municipal water, wastewater plants, which are easily calculated because the processes are nearly identical from one plant to another. Processes at the chemical, pharmaceutical, and food plants vary, and in some cases require considerable additional analysis. However, we can have more general forecasts like the total valve spend at a food plant without necessarily getting into the more specific details, which we can more easily do with some of the other industries. Forecasts for the more complex and smaller customers can be integrated later. Ultimately, customer forecasts for specific valve designs and for smaller plants can be integrated. In the total view here, there are, as you can see, these 70, 80, 84,000 units that comprise 90% of the total $64 billion market. And 30,000 of those units are in energy, 40,000 are in municipal water and wastewater, 4,000 in metals, food and pharmaceutical, 5,000, and then a range of other industries, which would be another 5,000. But the number of unit forecasts immediately available, covering 60% of the market, gives you 15,000 in energy, 15,000 in the water, wastewater, et cetera. So you're at 33,000 units that you would be receiving the data on an Excel file with the plant name and location and the forecast for valve spend, either total valves or It could be some single type of valve or for all types of valves. So for the 25,400 power generation plants, 7,000 of them are coal units, and these are the individual units. So there might be units like 1 through 4 at a plant, each of them being a 600 megawatt boiler. And by the way, that would be about $1 million a year in valve spend for each 600 megawatt unit. But the average plant is only about 540. Average unit is smaller, so you're talking 540,000 a year for valves. Nuclear, the average unit, and again, there could be 1 or 2 units at a plant, would be 1.8 million per year, but you're only talking 400 of the nuclear units. There are lots of gas turbines, and they're smaller, and the average unit spend when you combine the combined cycle with simple cycle, it's about 90,000 a year for valves. Now we do have tracking systems for hydro, geothermal, and biomass, and those are relatively small units, but we can cherry pick out the larger units and include them in the database. We have a lot of background details. I'm going to pick just 2 areas of the world. The U.S. is still a very attractive area because you're going to have long-term coal-fired power plant operation at around the 200,000 megawatt level. And AEP would be one example that operates 38,000 megawatts of coal-fired generating capacity in the U.S. and spends $40 million per year on valves. And so that's the total generating capacity, but the 17,000 megawatts of supercritical coal-fired boilers generate purchases of 30 million per year on valves. And in a particular example, we would have the John W. Turk unit, which started up in 2012. It's 600 megawatts, and it has SCR and pulse jet baghouses, but it has a dry FGD, and it's burning low sulfur coal. Now, most of the rest of the AEP plants have wet scrubbing systems, so the valves per unit on the other AEP systems are actually higher because of all the wet scrubber applications that they have. Here's an example, for instance, of EVN. Their Genco 3 Vintan 2 site has a total of 1330 megawatts of coal-fired capacity, and they're using precipitators, SCR, and they're using seawater scrubbing, so the valve spend would be higher than dry FGD, but less than the limestone FGD. Alstom was actually awarded both 660 units for both the seawater scrubbing and the SCR, and so they would have been the ones that would have been selecting valves and pumps and other components for the plant. So the valves spend can be carried out or calculated for all valves or certain types of valves. But for all valves, the valve spend for that plant will be $1.86 million. And that because there are 2 units there, each with 930,000 that will be spent for valves each year. So we can also provide forecasts for all the EVN plants, and they operate 26,000 megawatts of coal-fired, hydro, and gas-fired plants. Valve purchases will be $39 million per year for all these plants in 2013 and 2019. So this is an example, for instance, for the unit 1, which is the one of the 2 units there, and they will be spending in 2019 170,000 for ball mills, 120,000 for butterfly valves. I said mills, I meant ball mills also generate the the need for valves, but all the valves would be $170,000. Globe valves, $190,000. Plug valves, $100,000. And they'll be purchasing $150,000 worth of gate valves. And again, Vintan 2 per unit will spend $930,000 per year for valves and $1.86 million for the both units. So let's move on here to the big U.S. gas turbine market. So NAFTA is the leading purchaser of valves for gas turbine plants with a very large installed capacity. Actually, the East Asia is catching up with it now, and but it will reach 620,000 megawatts by 2021. And the region will account for a third of the capacity, and it's going to be growing but more slowly than East Asia. But the new gas turbines will amount to 18 gigawatts per year in NAFTA, and 10% of the existing valves will be replaced because of wear and tear. So this results in a replacement valves of 62 gigawatts and only 18 gigawatts of valves for new plants. And then when you add in the repairs, you see where the existing plants are spending the bulk of the money for the gas turbine valves. And the growth, as you can see here, is more substantial in East Asia, where in they will be adding capacity of 52,000 megawatts over the 3-year period, where NAFTA will be only adding about the same amount, but it will be operating twice as much capacity as East Asia. So half of this total will be high performance valves, and those are valves where they're definitely the decisions getting made on lowest total cost of ownership. So this longer relationship that you generate by focusing on these individual units is particularly valuable for any of the high performance valves. But the top 100 gas turbine plant owners will spend $542 million for high performance valves in the NAFTA region. So the other aspect of what we're doing is these decision systems. So we're getting into flow accelerated corrosion and how that impacts valves, and the cost of valves based on that, and the life of valves based on that. Problems with a lot of the process equipment like these superheaters, and that is going to generate more opportunities for valves and actually for monitoring those valves in a more sophisticated manner as well. As we were talking about before, there's only going to be 18 gigawatts of new valve purchases, and you've got the replacement of the 62, and then therefore you've got the purchases by the top 100 owners will be about $542 million in total. More than 20 corporations are buying more than $100 million per year in valves. So Sinopec is both an operator of chemical plants, oil and gas, and it's also involved as an EPC. So Sinopec is going to be spending over $900 million for valves in 2019. And NTPC, EDF, Eskom, Bechtel, and then even BASF, who's a large chemical company, will be spending $175 million for valves in 2019. Here's an example in China. You've got BEWG, which operates 400 municipal wastewater plants in China, Singapore, and Portugal. It also builds wastewater treatment plants. So it has a number of options for buying valves. So the bulk of purchases for its own plants will be for replacement and repair. If you look at the totals over here, new valves is only 900,000, but you've got the almost 9 million for replacement valves and repairs. And the Chinese government has got all sorts of efforts going on to increase the energy efficiency and making changes to the plants. So there are a number of changes going on. For instance, new blowers going in all the time, and this requires new valves and things to go along with those. There are substantial expenditures by some of the larger wastewater plants in the United States. LA County with several plants will be spending $11 million a year. And we've just picked units in this particular area to give you an example, from some of the very large to some of the not so large. But even San Jose Creek West will be spending $3 million per year for that operation. And we've done a lot of work that based on MGD and the types of treatment processes to work out the forecasted purchases, and a number of our estimates have been confirmed in the field. And of course, the municipal wastewater treatment industry has a proliferation of case histories and analyses by consultants, so that it is a lot of food to digest, or a lot of good information to determine not only valve costs, but the total cost of operation or ownership. So 90,000 municipal wastewater plants around the world will spend $4.5 billion for valves in 2019. This includes 16,000 plants in the U.S. that will spend $1.1 billion for valves. Now, of that, 3,500 plants will spend more than 100,000 each, and some large utilities with multiple sites will spend 20 million each. So the low-hanging fruit, obviously, is the 3,500 plants that will each spend more than 100,000 per year, which certainly makes a sales effort worthwhile. The semiconductor industry is much more compact, consolidated, concentrated. So Intel will be spending $68 million on valves next year, compared to $52 million for Samsung. Now, $44 million for TSMC, and there might point out that TSMC is actually a foundry, so they're really a chip manufacturer. So per unit of dollar volume for the corporation, TSMC buys many more valves than some of the larger companies who have their own semiconductor operations, but most of their revenue is generated from the sales of computers and finished products. The pulp and paper companies will account for nearly $1 billion in annual valve purchases, and International Paper, which has plants all over the world, will be buying pretty close to 18% of that total. Nine Dragons will be spending $90 million, or 9% of that total. WestRock, UPM, and Stora Enso will also be major purchasers. The pharmaceutical industry is a little bit more spread out, less concentrated, but even so, the top three purchasers will buy 10% of the valves, and the top 25 will buy 45% of the valves. And the pharmaceutical industry as a whole will buy valves valued at $1.75 billion. And at the top will be Pfizer with 80 million, and Roche at 60 million. One of the interesting things to view here is that many of these plants are US and others are European. So a lot of the sales decisions are going to be made in the United States, for example, for Johnson & Johnson and Pfizer and so forth. So the opportunity for the US-based sales force is going to be particularly large. The chemical industry is also fairly diverse, but the top 10 companies will buy 10% of the valves, and the top 200 companies will buy 40% of the valves. The top 1,000 corporations will buy 80% of the chemical industry valves. We're starting with this program where you, at the bottom of the pyramid here, are generating these purchase forecasts for all prospects. Then for the larger prospects, we can help you with a direct sales program that includes lowest total cost of ownership validation and other tools that are necessary when you're dealing with a company on a continuing basis, and that company is conducting data analytics and other and has other tools at its disposal to look at the performance of all the valves in its network of plants. It's going to be working at a very high level, and the lowest total cost of ownership validation is going to be one of the keys to success. And then we have custom websites for top prospects that that we can help you create. And so you have a tremendous interconnection with the technical people as well as the purchasing people at these plants. And we do have a number of analyses of the big sea change that is happening in the valve industry, which is going to result in the monitoring of many of the valves on a continuing basis, the lowest total cost of ownership validation that we've just been talking about here, and the development of subject matter ultra experts that are working not as static experts, but looking at all the knowledge systems and decision systems that companies like ourselves are creating and continuing to be even much more expert. And they will impact the valve decisions of the owner and therefore the fate of the supplier. And the valve supplier also has to consider the third-party O&M suppliers, for instance, on gas turbines where you have a lot of that third-party operation. And of course the automation suppliers, and then process management. If the whole system is going to be managed through the cloud, then this is another consideration. And for valve manufacturers, edge computing to feed into the cloud is going to be a big additional revenue generator. But in all these cases, it starts with the forecasting of how big the opportunity is going to be, and that's what this new system does. I'd like to thank you for spending the time with us today, and this is Bob Mcilvaine saying that be glad to answer any questions that you have. We're going to be doing similar webinars on pumps and other subjects in the next month or two, and I will look forward to seeing you with us again. This is Bob Mcilvaine signing off for today.